Welcome to Bioinformatics.Expert. In this video, I want to show you a new functionality of the program Bioinformatic Tools Online. Besides RNA sequencing datasets, you are now able to analyze also Amplicon-sequencing datasets. I created FastQ files which contain artificial sequences of a paired end Amplicon sequencing experiment. I created them in that way that we have 10,000 sequences that are all 150 bases long, and the quality of the bases is designed in that way that it is decreasing towards the 3' end. This is a common observation in FastQ files, and it means that the bases at the 3' ends are most likely to contain errors. However, to show you how the pipeline deals with those errors, I created the sequences in that way that with a probability of 1 to 1000, a mismatch or insertion is introduced into the sequence. Finally, I designed the reads in that way that 20% of them contain a 10-base deletion compared to the reference and 20% contain a 10-base insertion compared to the reference. Before we start the Amplicon sequencing analysis, we take a look at the pipeline scheme. In the first step, we perform a read connection. That means we connect the R1 and the R2 read to a new merged sequence. The merged sequence is created in that way that ambiguous bases in the forward or in the reverse read are corrected with the quality value. To start the read connection, just press the button in the table. First, we have to select the FastQ file which contains the R1 reads. Then we have to select the FastQ file with the R2 reads. And finally, we need the reference which should be used for the connection. In the parameter table, we now see that we can also change some of the parameters for the connection. For example, the overlap of bases or the number of reference boundary bases for the final sequencing extraction. That means in that case, how many bases from the reference should be used to define the boundaries in the reads. Also, you can decide if you want to allow mismatches or insertions or deletions in the sequence boundaries. However, I suggest to just leave the parameters as default right now. As output, we will get the connected both FastQ file, which contains the connected sequences. However, we also get FastQ files of the reads which are only aligned at the left side or the right side, or which don't align at all. If most of the sequences are located in that files, then probably the reference is not okay and you should revise it. An R script is executed which aligns the boundary bases of the reference to each read. That means the left boundary bases to the S1 reads and the reverse complement boundary bases to the R2 reads. In the next step, all upstream bases are chopped away and the R1 and the reverse complement R2 reads are connected. As I said, the quality string defines the correct base if the result is ambiguous. Here you see the results files and the report file which shows you the output of the connection. Before you continue, you should take a look at this file to see if the connection worked, because if something went wrong, you can see it here and restart the analysis. Before we continue, I want to show you what happens to the reads after connection. So let's do a FastQ-see first. You see that the quality values are now much better at both sides of the reads. We see this dip in the middle. However, this is because these files are artificial, and in normal files this probably would not occur. So now we have combined reads which start and which end with the same basis as the reference. That means we can now do a global alignment, which is an alignment from end to end to find out the sequences between the boundaries and to see if our sequence is similar to the reference or not. Just click the Global Alignment button in the table and then select the connected both FastQ file which was created in the previous step. We also need the reference for the global alignment step, and then we are at the parameter table. Here you see that you can omit sequences which are below a specific length or above a specific length. The 0 and the 10,000 here means that all sequences are included in our analysis. During the global alignment, different events influence the alignment score. For example, a match can increase the alignment score, whereas a gap or a mismatch can reduce the alignment score. At the end, the alignment with the highest score is considered to be the best alignment. During development of that program, I found out that these parameters here give very nice results. However, you're always free to change them and to experiment with the output afterwards. Now start the analysis, and again an R script is executed which performs the global alignment and collects the result in a text file. When we open the text file, we see that it is a tab delimited text file. That means it can be easily imported into Excel for further analysis. Additionally, there's also a reports file in which we can see how the alignment works. We, for example, see that about 53% of the reads perfectly align to the reference. In the last part of the video, I want to show you a visualization tool for the text file of the global alignment. As I said, you can insert it into Excel for your own analysis. However, with this tool, we can create the results as table format for better visualization. Just click the visualization button in the table and then select the alignment file text file. We now need to select how many results should be shown in the table. For example, if we leave this number at 10, then only the top 10 results will be shown. Then we have to select how the table should be sorted. For example, we can choose number of reads and the sorting direction decreased. That means the top results will be the sequences which are most abundant in the dataset. Now start the analysis, and again an R script is executed, but this time it creates the reports file as HTML file and PDF. We can directly open the HTML file in the browser, and here we see the results table. Each row contains two buttons, Remove Deletions and Show Alignments. When we click on Show Alignments, then the alignment to the reference is shown. When we click on Remove Deletions, then any occurring deletion is removed, so you can better copy-paste the results. Finally, also a PDF file is created without the buttons. Okay, so this is it. This is the basic analysis procedure for Amplicon-sequencing data using Bioinformatic tools online. In the next video, I will show you the program read merger, which you can use to optimize your results a little bit. And I will show you the program oligo search, in which you can easily search for oligos in your sequencing results. If you have further questions regarding the Amplicon sequencing analysis pipeline, you can download a manual directly from the webpage. However, you can also write me an email to clarify some problems or questions. So if you want to use the program Bioinformatic tools online in your research, also the RNA sequencing part, or maybe also the other parts which will come later, then write me an email or visit my webpage.